All right, we're going to review chapter 11 today. I'm going to try and get it all in one video, but it might take two. The very first section of the chapter had to do with exponents and radical expressions, and you might have started with problems that look similar to this. We had to remember that a power raised to a power, we multiply, and if the base numbers are the same and we're multiplying, we add the power. So on this one, the 3 is applied to the 3, so that's 27a to the negative 6 times 3a to the 5th. Well, if I have a negative 6 exponent, that means it's going to go on the bottom. So this is going to be 81 a to the 5th over a to the 6th. If I have base numbers are the same and I'm dividing, I subtract exponents and put the remaining exponent where the larger number is. So 6 minus 5 is 1, so the 1's going to go on the bottom. So I get 81 over a as a final answer for that type problem. Then we went back and forth between radical expressions and exponents. So let's say I have something like this. The cube root of ax to the 6th, y to the 12th, and it tells me to express this radical expression as exponents. Well, the cube root is the same thing as saying 1/3. So I have that. That's how I change it. Then I have to apply the 1/3 onto each thing. So I have 8 to the 1/3 power, x to the 6/3 power, y to the 12/3 power. The cube root of 8 is 2. That would be x squared, and this one would be y to the 4th, okay? Then we might go the other way around. We might take the exponent form and change it to radical expressions. So you've got to be able to do that as well. All right, notice that I cannot put it under a radical right now because this is a 4th root and this is a square root. So I want to get a common denominator. The common denominator is going to be 4. So I can write it like that. The 16 doesn't have any power on it, so that's going to go on the outside. This is going to be the 4th root of x to the 3rd power and y to the 2nd power. All right, that was our first section in chapter 11. The second section had to do with graphing exponential functions. And this is where we talked about like the coronavirus curve, that we talk about something growing exponentially, that it has a high peak to it. So you've got to be able to graph these things. You might have inequalities, you might have equal, you got to be able to graph both. We'll just do one inequality. There are also some word problems on these. Let me make sure that video is still recording. Okay. All right, and I'm going to just plug in. So let's say I plug a 0 in for the y. If I have a 0 there for the y, I have 2 to the negative 0 power, or I would have 1 over 2 to the 0 power. Anything to the 0 power is 1, so that's going to be the 0.01. All right, let's say I put a 2 there. That's going to, or I put a 1 there. That's going to give me 1 over 2, or 1/2, okay? Let's say I put a 2 there. If I put a 2 there, that's going to give me 1/4, okay? So I'm going to get lower and lower. Let's say I have a -1. Well, that's going to give me a -1, or a 2 to the 1st power. So you can see our curve right here. Now, it would be a dotted line, and it says it's below that line, so it would be everything down here. So hopefully you can get those graphed without any problem. We also did some word problems, and so let's talk about one of those. Most of these are finance problems. Let's say we want to know how much money we are going to receive if we invest $1,700 at at a rate of 6.3% for 8 years, and the interest is compounded quarterly. Okay, now if it's not continuously compounded, continuous compound, we can use the PERT formula. But this is going to require me to use this formula. So make sure you know both. Actually, this one can be used continuously if your N is 365. But on this case, my N is going to be 4 because I'm compounding quarterly. So I'm going to plug in 1700, 1 plus, I got to take my percent and change it into a decimal by moving the decimal, over quarterly, so my N is 4, and 4 times 8. So if I plug that all in my calculator, just put it in, make sure your parentheses are in the right location, I should get 2,803. All right, that was section 11.2. Section 11.3, we began to talk about the number E. Remember, E is on your calculator, and it's equal to 2.72, and it is used in things like the PERT formula. An example of this would be you are going to invest $5,000 at a rate of 8.5%, and you're going to compound it continuously and for 10 years. So you're going to use the PERT formula if it's compounded continuously. So I have 5,000 times e raised to the 0.085 times t power, or 5,000 times, I'm going to move it over one place, decimal, raise to the decimal 85 power. Remember, E is on your calculator. It is right above your division sign. So I just put that into my calculator. I raise it to the 0.85%, and I get $11,698.23. Okay, sometimes they're going to ask you to compare that to something compounded like quarterly or, annually. So my $5,000 investment becomes a huge investment after 10 years if I can find something that's going to pay me that interest rate. All right, then section 11.4, we began to talk about logarithms. You have to be able to go back and forth between logarithms and exponential form. So let's say I have this, and they tell me to put it in exponential form. Remember, the base here is the base there. This is my exponent, and that is my answer, that same form. Or, let's say I start in exponential form, and I want to put it in logarithmic form. The base here is the base there. The power here is what it's equal to, and what the answer there is what's going to go right there. So the log of base 2 of 32 is 5, same thing as 2 to the 5th power equals 32. All right, we use this to evaluate. So let's say I want to know what the log of base 5 of 1 over 25 is. All right, the easiest way is to put an x there and rewrite it as an exponential form. 5 to the x power is equal to 1 over 25. That, I want the base numbers to be the same if I can. Later on, I can't make the base numbers the same, so I have to do it a different way. But that's 5 to the negative 2 power, or x is equal to negative 2. The other way to do this is on your calculator. Remember, you can use common log, or you can actually use natural log to figure this out. But the common log of 1 over 25 divided by the log of 5. Do not forget to put the closing parenthesis behind what you're taking the log of. When you press log on the calculator, it's going to give you the first parenthesis. Then put your number in there, then put your closing parenthesis, then do your division. All right, and that's also going to give you a negative 2. So you can do it on the calculator, you can do it by hand. All right, let's do one that we're going to solve. And I'm looking here, don't forget all of your, and I probably should have already written this down, but let me go back. We'll pause right here for a second. Don't forget all your properties, okay? The log of base P of M times N is equal to the log of base P of M plus the log of base P of N. Remember, multiplication can be written as addition. Then division can be written as subtraction. So you have the log of base P of M minus the log of base P of N is the same thing as M over N. And then we had one where we had an exponent. And remember, we learned that we can bring that exponent to the front. So the log of base P of M raised to the n power is equal to n times the log of base P of M. Then this one is the one that I was reminded me that I hadn't written those out yet. So make sure you know how to use those. If I have a logarithm the same on both sides, it's like I'm dividing by it, I can cross it out. So I have 4x plus 6 is equal to 8x minus 2. If I subtract here, I get a negative 4x. Subtract there, I get a negative 8. X is equal to 2. If I get a negative power there, I want to put it back in here and make sure I'm not changing a positive to a negative by use of an exponent, because that's important. All right, let's do another one of those. All right, I don't just have one logarithm on each side. I've got two here, so I got to see what I can do. If I'm adding, remember it's the same as multiplying. So I can rewrite this as x times x minus 2. So I have the log of base 9 of x squared plus 2x equals the log of base 9 of 3. Now I can mark those out, and I get x squared plus 2x equals 3. I'm going to subtract 3. Check the video. All right, I just don't want to run out of time. Okay, so I have x plus 3 and x minus 1. Then I'm going to solve both. X is equal to negative 3. X is equal to positive 1. Then I have to plug back in, because that's saying the log of 9, base 9, of something. So it's saying 9 to something power is going to give me negative 3. That is absolutely impossible. There is no way for me to change a positive into a negative by using an exponent. So that one doesn't work. That one's the only one that works. All right, 11.5 was common logs. This is the logarithm button on your calculator. It all has a base of 10. And that's when we began to talk about the shortcut on how to do things like this. All right, remember that's equal to the log of base 10, which you don't have to put in there because that's your button on your calculator, over the log of 8. And that's going to give you 3.6641, okay? Then we use this concept to solve problems. We continued to solve them the same way the next section, but the next section used natural log. So let's say I have that, okay? There's no way to make the base number the same. So I'm going to take the log of both sides. I'm going to bring that 2x to the front. Actually, I'm just going to bring the x to the front. And I'll leave the 2 on the 7. So then I'm going to divide by the log of, if you will, 49, because 7 squared is 49, log of 49. And that's going to give you what x is equal to. So x is going to give you, let's let's see, it's going to be 1.1646, depending on where they tell you to round it. Okay. All right, then we went on to the next section. The next section was natural logs. Remember, the natural log is the base of e, and it's the LN button on your calculator. There's on occasions you have to use the anti-log or the anti-common log. So remember, you can use second log to get the anti-common log and second LN to get the anti-natural log. Now, sometimes what they'll do is they'll give you this, and they'll say convert to natural log and solve. Well, all that means, and it really doesn't matter whether you're going to get the same answer. You can do it like this. This is converting it to natural log. Or you can keep the logarithm of a common log. Either one of those is going to give you the same answer. It's going to give you 4.2868. Now remember, I can't do common log and natural log in the same problem, but as long as I stick to natural log or I stick to common log, it's going to give me the same answer. So let's solve one where you'd have to use the natural log in it. Oh, wait a minute. Let me see how much time's left on that. I think I'll pause it and we'll start a new video, okay?